Yesterday, amidst the flood of data from observatories and radio telescopes, an alert caught my attention. A pattern of impulses, repetitive and precise, was detected on a frequency any radio astronomer would immediately recognize: the hydrogen line, that waveband we have monitored for decades as the most universal channel of the cosmos. What troubled me most was not the frequency itself, but the sequence of numbers it was purportedly encoding: 8, 13, 8, 5, 13, 8. Within hours, the news of an alleged interstellar message spread across forums and social networks. It was not the first time such a rumor ignited collective imagination, but this time the focus was on an object that had already surprised us before. These numbers, 8, 13, 8, 5, 13, 8, seemed linked to one of the most famous mathematical patterns, the Fibonacci sequence. The possibility that a comet was sending messages following this pattern was fascinating. But what was true in it? To understand, I had to delve into the details of the story, consult colleagues, verify data, and reflect on what drives us to see signals where perhaps there is only noise. When the rumors about the message began, I felt a mix of enthusiasm and skepticism. After all, my work involves deciphering patterns in the cosmos, and I know how easily a natural phenomenon can be mistaken for an intelligent signal. In a world where a new theory about conspiracies and mysteries emerges daily, it was predictable that such news would spread quickly. Checking my emails, I found messages from friends unrelated to science asking if it was true, and from colleagues inquiring whether there were data to support the rumor. The initial reaction of many was to assume it was a publicity stunt or a prank. However, upon deeper investigation, I discovered the story stemmed from posts by amateurs who interpreted data without access to the original source. These posts claimed a modulation had been detected at the frequency of 1420 MHz and that, by converting the intervals between impulses into numbers, the Fibonacci sequence emerged. Some even asserted the message was encoded as a warning in Spanish, something like observe, prepare, understand. It didn't take long for me to wonder where this phrase came from. No one could provide an official record of the signal, a graph, or any instrumental evidence. It was as if the message had appeared out of nowhere and gone viral solely due to its narrative appeal. Much of the rumor's impact lies in its components. The Fibonacci sequence is a numerical series where each term is the sum of the two preceding ones: 1, 1, 2, 3, 5, 8, 13, and so forth. This sequence appears in nature in growth patterns. The leaves of many plants are arranged on their stems at angles related to the golden ratio derived from the series. The spirals of sunflowers and pine cones follow Fibonacci numbers. Even the spiral arms of some galaxies seem to align with related proportions. This series has fascinated mathematicians and artists for centuries, as its quotient approaches the golden ratio, an aesthetically pleasing value of 1.618, supposedly found in classical architecture. Linking the Fibonacci sequence to an extraterrestrial signal is highly appealing, as its universal nature makes it an ideal candidate for encoding messages that any advanced intelligence could recognize. Add to this the frequency of the hydrogen line, considered the natural standard for cosmic communication, and you have an irresistible combination. The idea that someone in the cosmos is using a mathematical language to communicate with us is the dream come true of any space enthusiast. I myself, during my training, considered the possibility of sending messages based on prime numbers or the Fibonacci sequence as a way to indicate a signal is not natural. Nevertheless, the story's allure is not enough to confirm its veracity. For a radio telescope to detect an artificial signal, it must pass several filters. First, the impulses must exhibit a periodicity that does not match known natural phenomena. Additionally, this periodicity must persist over time and be reproducible at other observatories. However, the alleged sequence of impulses attributed to the Comet 3I Atlas did not appear in any reliable database. After consulting colleagues at the Institute for the Search for Extraterrestrial Intelligence, I was confirmed that no extraordinary detections were recorded at this frequency. The world's most advanced radio telescopes, such as the Allen Telescope Array, continuously monitor frequencies near the hydrogen line. Any coherent signal would have been detected and verified from multiple locations to rule out terrestrial interference. Moreover, the alleged sequence, 8, 13, 8, 5, 13, 8, does not align with the natural start of the Fibonacci sequence, which begins with 1, 1, 2, 3, 5, 8. It is true that 8 and 13 are consecutive numbers in the series, but 5 is 2 positions before 13, not immediately prior. So why was this combination chosen? I had the impression someone was forcing the data to fit a mystical narrative. When searching for a pattern, it is easy to select data that confirms what one wants to see. This tendency is dangerous in science, as it can lead to erroneous conclusions. To grasp the rumor's scope, one must also consider the context in which it arose. The Comet 3I Atlas had already captured public and media attention, as it broke several records and exhibited phenomena that did not align with known comets. Its near-perfect alignment with the plane of the planets and its passage through strategic points of the solar system led some to speculate it could be a probe. Its anti-cometary tail surprised those who expected it to always point away from the Sun. Its large mass and composition, rich in carbon dioxide and nickel but low in water, sparked debates about its origin. Its extreme negative polarization puzzled optics specialists. Its sudden non-gravitational acceleration and bluish hue as it approached the Sun added to the list of anomalies. All this predisposed the public to believe any unusual story about the comet. Thus, when someone suggested it was emitting a message, the idea found fertile ground to spread. Another key piece of the story is distrust in institutions. During the approach of 3I Atlas to Mars, several missions around the red planet captured images. The Chinese probe Tianwen-1 took photographs where the comet appeared as a bright point surrounded by a luminous coma. The European ExoMars mission also obtained images, though the object appeared fainter. The National Aeronautics and Space Administration, however, delayed releasing data captured by its orbiters, partly due to a government administrative shutdown. This delay was interpreted by some as a deliberate attempt to conceal information. Conspiracy theories suggested the images showed structures or light emissions the agency did not want to disclose. This distrust fueled the notion of possible secret signals. Yet, in reality, space science follows strict protocols. Images must be calibrated, corrected for camera geometry, and cleared of artifacts. Moreover, the involved teams include dozens of scientists from various countries, making coordinated concealment unlikely. I have worked with mission data that can take weeks to process before release. However, the public rarely considers these details and prefers to embrace intrigue. The numerical sequence was also interpreted as a code. Someone added the digits and proposed that 8 plus 13 plus 8 plus 5 plus 13 plus 8 equals 55, a number also belonging to the Fibonacci sequence. This coincidence was presented as further proof. Then it was claimed the numbers corresponded to words that, when decoded, formed a message in Spanish. It is easy to see how such a narrative is constructed. Data is selected, assigned arbitrary meaning, and linked through forced analogies. But science does not work this way. For a code to be deemed valid, it must be reproducible and possess internal logic that can be independently deciphered. In the famous Arecibo message, for example, we sent a binary pattern that, when arranged into a matrix, described a human figure and basic chemical elements. If an extraterrestrial intelligence decodes it correctly, it will understand it is not noise. Claiming a comet's impulses say understand in Spanish, however, is baseless. Another factor contributing to the story's spread was the involvement of prominent figures. Abraham Loeb, who has defended the hypothesis that some interstellar objects might be techno-signatures, was a key figure in these debates. His suggestion that 3I Atlas could be a probe sent by another civilization was interpreted as support for any exotic hypothesis. Although Loeb did not mention the message, many associated his name with any idea related to extraterrestrial contact. Media coverage often simplifies his arguments, reducing them to sensational headlines that fuel the perception that something significant is being hidden. I respect the courage to propose unconventional hypotheses, as open-mindedness is essential for generating new ideas. However, in science, the improbability of a hypothesis does not make it automatically true. Plausibility is built on evidence. Beyond the rumor, it is true that the hydrogen line frequency is relevant for searching for messages. In the field of the search for extraterrestrial intelligence, it has been proposed that any advanced civilization would know that hydrogen is the universe's most abundant element and that its hyperfine line has a defined frequency. Thus, many extraterrestrial intelligence search projects monitor this band for an artificial signal. Detecting an impulse periodically modulating this frequency would be a historic event. Precisely because of its significance, astronomers have developed filters to distinguish natural from artificial signals. Natural sources emitting in the hydrogen line include neutral hydrogen clouds in the Milky Way, supernova remnants, and the solar corona. These emissions are diffuse and have a characteristic spectrum. An artificial signal, conversely, should be narrow in frequency and exhibit a non-natural modulation pattern. A claim by someone without access to radio telescopes that they detected such a signal is hardly credible. Detecting an extraterrestrial signal requires advanced infrastructure and international collaboration to verify its origin. Behind the Fibonacci signal story lies a sociological phenomenon, the need to believe. We live in an era where information spreads at unprecedented speed. Conspiracy theories feed on distrust in institutions and fascination with the unknown. When a topic combines mathematics, astronomy, and the possibility of extraterrestrial life, it creates a perfect storm for people to share without verifying. I have seen even academic friends, accustomed to scientific rigor, forwarding dubious articles because the story was too compelling to ignore. This is a lesson in humility about how our minds are wired to seek patterns and connections, even when none exist. In psychology, this is called apophenia, the tendency to find meaning in random data. In most cases, apophenia is harmless, but in science, it can be dangerous if it leads to erroneous conclusions. It is pertinent to reflect on what would happen if we ever received a genuine message. The scientific community has extensively debated what to do in case of contact. Some believe we should respond immediately, sending information about our location, culture, and biology. Others warn that revealing our presence to unknown civilizations could be risky, as we do not know their intentions. This discussion, known as messaging extraterrestrial intelligence, raises ethical and practical dilemmas. A message would have implications not only scientific but also cultural, religious, and political. In the case of 3I Atlas, the idea that a comet is speaking to us evokes ancient tales when these celestial bodies were seen as omens. If we ever detect an authentic signal from an interstellar object, we will need to decide collectively how to proceed. For now, it is prudent not to send messages without global debate. The renowned astronomer Carl Sagan advocated for caution and collaboration. I like to think that, if it ever happens, we will respond as a species united. Meanwhile, comets like 3I Atlas have much to teach us. They are time capsules preserving the chemistry and physics of the places where they formed. Analyzing their composition allows us to learn about protoplanetary disks of other stars. Studying their dynamics reveals how objects behave beyond a sun's influence. Their surprises force us to rethink our theories. Each anomaly of 3I Atlas is a challenge and an opportunity. The anti-cometary tail prompts us to investigate how gas jets can be unusually oriented. Its large mass invites us to consider other processes of material accumulation in interstellar space. Its composition, rich in carbon dioxide and nickel, makes us think of formation regions distinct from the Oort cloud. The negative polarization pushes us to study new types of dust. The coincidence with the WOW signal reminds us that the cosmos is full of intriguing coincidences. And the non-gravitational acceleration compels us to refine our equations of cometary dynamics. In the months following perihelion, as the comet moved away, I recontacted radio telescopes to confirm that nothing resembling a message was detected. The response was always the same: no artificial impulses. Some, like the Arecibo telescope, which once sent a message to the star cluster M13, are sadly no longer operational. Others, like the Fast Radio Telescope in China, are active and could detect signals but reported nothing unusual. Moreover, most extraterrestrial intelligence search projects are open to the scientific community and the public. They publish their data for anyone with expertise to analyze. If something strange were found in the hydrogen line, the world would know. Researchers would have no reason to hide it, as such a discovery would be the greatest achievement of their careers and of humanity. The perception that the National Aeronautics and Space Administration is withholding information also warrants analysis. While the agency made communication errors during the government shutdown, there is no evidence it is hiding interstellar messages. Like any large organization, it is subject to bureaucracy and processes that may seem opaque. However, scientific information is not confined to one institution. Dozens of agencies and universities worldwide participate in research. Data is shared, reviewed, and published in peer-reviewed journals. In the case of 3I Atlas, the teams responsible for Mars images include scientists from various countries. If something unusual were present, a leak would be inevitable. Furthermore, we live in a world where amateur telescopes can capture astronomical events and broadcast them in real time. The possibility of hiding a message from another world is practically non-existent. Stories of comets sending messages are not new. In the 19th century, when Halley's Comet returned, it was attributed supernatural powers. In the 1990s, the comet Hale-Bopp was linked to cults that believed a spaceship accompanied it. Attributing meanings to these celestial visitors is part of our culture. Today, in the Internet age, such narratives spread faster and adopt a pseudoscientific language. However, this also presents an educational opportunity. Every rumor is a chance to explain concepts like the Fibonacci sequence, the hydrogen line, or the difference between signal and noise. When asked if a comet could send messages, I seize the opportunity to explain the process of searching for extraterrestrial intelligence, how radio telescopes scan the sky, how terrestrial interference is filtered, and how data is verified. Thus, a rumor becomes a tool for teaching science. Ultimately, the fascination with the idea of a message addressed to Earth reveals a deep desire for connection. We want to know if we are alone, if there are other beings who also contemplate the stars and ask the same questions. This desire has driven generations of scientists to build telescopes, send probes, and develop theories. It has also inspired literature, film, and music. We should neither ridicule nor suppress it. But we must channel it with rigor and patience. Science cannot promise immediate answers. Sometimes, the most important questions take decades to answer. In the meantime, our imagination fills the uncertainty with stories. That is natural. The important thing is not to confuse stories with reality. If the story of the 3I Atlas signal has left anything positive, it is the renewed interest in radio astronomy and the search for technosignatures. Many people have encountered concepts like the Fibonacci sequence or the hydrogen line for the first time. Others learned there is a serious debate about whether we should send messages into space or not. And some understood that science is a process combining data, hypotheses, and verification. Often, extraordinary claims inspire more people to study and engage. Although the rumor proved false, its impact was not entirely negative. It served as a reminder of how extraordinary it would be to find a real message and how much we still have to learn. So, returning to the initial question, is 3I Atlas sending a signal to Earth? The answer, based on available data, is no. There is no evidence that the comet emitted impulses at the hydrogen line frequency with a Fibonacci pattern. Observations suggest the rumors arose from misinterpretations and the desire to find something extraordinary. This does not mean the story of 3I Atlas is less fascinating. Its real anomalies continue to be studied. Science persists in analyzing its properties and seeking explanations. And ultimately, the rumors remind us of the importance of keeping an open mind, but also the necessity of distinguishing between possibilities and probabilities. I invite you to continue joining me in this scientific adventure. Every day, new information about the cosmos emerges. Some are real and have the potential to transform our understanding. Others are false but teach us to be critical. It is natural, when following a news channel about 3I Atlas, to seek novelties, surprises, and mysteries. I commit to presenting every anomaly, every discovery, and every debate with the utmost fidelity and enthusiasm. If you enjoyed this exploration, share it with friends, share your opinion, and prepare for the next chapter. For the universe never ceases to surprise us, and our search for signals from other intelligences continues. Perhaps one day, an interstellar object will send us a real message. When that happens, I want us to be ready to listen together, with the wonder and caution it deserves.